Yes.
All right, so 6-1, this is translations. On number 3, you're not going to have to show any work underneath because it doesn't tell you to list the coordinates. Okay, it just tells you to graph it. So go ahead and apply the translation, graph your new graph. Make sure you label it ABCD prime. Okay, for number 4, just make sure you're going from your pre-image, which is the one with the arrow on it, to your prime image when you are deciding whether you're going up, down, left, or right. All right, 6-2. 6-2 was reflections. Okay, not really much to say on this. Just make sure you read each one, follow the directions. Number 4, they're just asking you to pick the line of reflection. I would draw it in there and then decide if you're picking A, B, C, or D. Okay. All right, flip to 6-3. 6-3, we talked about rotations. Notice this is the one where you're really going to start marking in your book. Notice that I told you that if I ask you to do rotations, I would provide the graph for you from page 323. So I imported this image onto your packet before I printed it to make sure you all would have this. Okay, so when you're doing a rotation, if it's a 90-degree rotation, you have to apply the 90-degree rotation rule, point for point. Every single point needs to get that rule. So here's what your work's going to look like. And everybody needs to, don't fill it in yet, but give yourself this blank canvas to plug in answers, okay? And I want everybody to be writing this. And it even tells you, you don't even have to get them yourself. It tells you the coordinates for these, right? It gives you these. Then you have to apply the 90-degree about the origin rule from the graph, and then you have to fill in these. Okay, that's what it's asking you to do. And I have to see all of that work. All right, very similar to that, and I'll leave both of these up there, and then I'll walk the room, make sure everybody has these. Number 5, your work needs to look just like this. Now, this time they don't give you A, B, C, D prime. You got to find it yourself. Not prime, sorry, the pre-image. You got to figure out where the coordinates are, plug them in, then you need to apply the 90-degree rule to get your new coordinates, and then it wants you to graph it. So number 4 or number 3, you just have to list them. Number 4, you have to list them, then graph them. Okay, and I'm gonna come around, make sure everybody's got this. You will need, your answers need to look just like this. You're right. I was thinking it was 100 degrees, so that was the number of but then I realized this was a 90-degree. That's why. All right. Good. All right, move on to 6-4. Make sure you're with me page for page, guys. Okay, I want you to make sure your answers are the way they're supposed to be. So everybody should be on 6-4 right now. If you don't remember the definition of a sequence of transformations, where can you go? 6-4 in your workbook. Okay, that's why I left each one of those numbers up there so you would know right where to go. All right, not much here except on number 4, when it says describe a sequence of transformations, you cannot say moves, right, or flips. You've got to use the correct terminology. Okay, you've got to say things like translates, reflects, rotates. Okay, if you say translates, you're going to have to add up, down, left, right, so many units. If you say reflects, you're going to have to say across some axis or some line of reflection. And if you say rotates, you're going to have to say rotates about the origin, how many degrees. So there's going to be a lot of information in here. And because it's a sequence, you know there's going to be at least 2 moves. Okay? All right. Moving on to 6-5. 6-5 was all about congruency. How do we prove congruency? Remember, this was the symbol for congruency. How do we prove it? No. Through using a, what are you going to say? We want them to be the same size and same shape, but how do we prove they're the same size and same shape? of transformations. To prove congruency, you use a sequence of transformations. If you succeed using a sequence of transformations and they all land point for point, then you know it's congruent. If you try to do the sequence and at some point you hit a fail, then you know it's not congruent. But you have to run the test and you have to test the sequence of transformations, okay? Please don't ever just answer, are they congruent? Yes, because they're the same shape and same size. You have to prove it through a sequence. Yes. If you showed it on the graph, put no, but then it says explain. So put why. Put where it failed. Like, where did it fail the sequence? If you did a rotation, but then tried to do a dilation, or if you did a reflection and then tried to do a translation, put after reflecting across the this is not an answer. I'm just giving you an example. After reflecting across the y-axis, no translation line, mapped ABCD to KLMN. Okay, so you have to kind of put where it fails. If you're going to explain why it failed, tell me where it failed. Okay. All right. Same thing with number 3. If you're going to say yes or no, if it's yes, put the successful sequence. If it's no, put where it failed the sequence. Okay. All right. Describe the sequence of transformations, okay, to map DEF onto DEF prime. Okay, that's just kind of a review. What one could these be? If you're describing a sequence, what ones could you use here? You can use a reflection. What else could you use? These are just possibles. What else could you use? Can you use dilation on this particular one? If they dilate, they're different sizes. Are these different sizes? Right, so dilate can't be an option. You got it? So what's another one it could be? Olivia? Translation, and what's the last one that you could possibly use? Rotation. Dilation is in your toolbox, but in this particular case, you won't use dilation because they're the same size. Okay? Then you know if they're the same size, then dilation will not be, it says sequence, so you know you're going to have at least 2 steps. You know dilate will not be one of them. It's off the table because they're the same size. If one was little and one was big, then you would know one of your moves has to be a dilation. Yeah. All right. Let's see. This is all about dilations. Okay. Remember to find scale factor. You've got to set up that fraction. It's always prime over pre. Okay. So if you don't remember that, remember that your scale factor is prime, and it's either coordinate or side length, whichever one you're given. And these you're given coordinates. So prime over pre, find your scale factor. All right, for number 3, I'm going to leave this here again because it's very important that you show this work. What are the coordinates of image ABC after a dilation with the center 0, 0 and a scale factor of 3? Well, first you have to name the coordinates of ABC. Then you have to apply the scale factor and get new coordinates and then graph said new coordinates. And actually, technically on this one, you don't have to graph them because it just says what are the coordinates. So technically you don't even have to graph it. All right, are we good with that? Everybody have that down? Everybody has the little brackets. Everybody knows what they're filling in. Corbin, you good? Okay. All right, go on to the next. No, 6, 7. Whoops, I didn't erase this from earlier. All right, same thing with similarity. Similarity, you also have to prove it with that sequence of transformations. Okay. Or you can prove it with the scale factor. Okay, so you test. Now you don't have coordinates here, but you have side lengths. So you can test the ratio of these two right here are corresponding sides. So set them up as a fraction and reduce it. And then test it with these two. Set them up as a fraction and reduce it. Set them up as a refraction and reduce it. And then set them up as a fraction and reduce it. If all of them reduce to the same scale factor, then you know they're similar. Yes. Nope. Just if you decide to put figure 1 on top, make sure that it's always on top. That's all you have to make sure that it stays consistent. All right, here I got another set of kind of coordinates that you're going to fill in. Okay, you're going to name PQR by their vertices. Then you're going to apply that scale factor times 2. That's here, here, and here. You're going to get new coordinates. And then because it does say graph, you are going to head and graph it. And then I would underline this so you don't miss it. Then it's a step, another step. You are going to reflect that across the y-axis. So I would underline that so you don't miss. This is a two-stepper. You're going to dilate, then reflect. And then for number 4, very similar to the other ones where it's a sequence, you know there's going to be at least 2. You're not limited to 2. You can do 3, 4, whatever you need. But it's at least 2 because it's a sequence. And again, because they're the same size, I can take dilate off the table. So I know it's going to be translate, reflect, and rotate. And because it already tells you they're similar, you know there is a workable sequence. You just have to find it. You're not proving similarity where you can get a yes or a no. It tells you right here, yes, they are similar. So there will be a sequence that works. Okay. All right. Moving on to 6-8. Okay, 6-8 says, select all the pairs that are alternate interior angles. And notice right above alternate, I put opposite because a lot of times I'll say opposite instead. It means the same thing. Okay, they're opposite of each other. And when it says interior angles, okay, interior means inside the parallel lines. So you're only looking at the 4 inside, okay, these right here. These are your interior angles. So you're looking at which ones are alternate. So which ones are opposite each other. Okay, if it said exterior, which it doesn't, but if it said exterior, you'd be talking about these guys on the outside of the parallel lines. Okay, pretty self-explanatory, but I just want to go over it once with you. All right. Number 3, I think you guys can do this pretty easy now. Okay, you just got to kind of fill them all in. Once you fill them all in, you can answer number 3. And then number 4, I want to kind of walk you through because there's an extra parallel line in there and I don't want it to throw you. It doesn't change anything. Okay. It says in the figure DEF are parallel lines. What is the value of X? So before you can answer what is the value X, take that 70 and run with it and put it everywhere you can put it. Okay. Or at least start putting it where it helps you with the X minus 20. So where else could I put a 70? Think interior opposites or alternates. Above the, right here. Okay. Because I know in parallel lines, these guys are parallel. And I also know that this one is 70, either one. It doesn't matter which one you start with, but you can get to the point where you know that that equals 70. Now, are these two creating a straight line? Yep. So I'm going to help you set this up. Okay. We know that this angle, every time, we know that this angle is the X minus 20. So we can say that X minus 20 plus, we know this one over here was 70, right? And we know that those two angles together equal 180. Corbin, you just want to borrow this so you can keep up with us? You sure? Okay. All right. So now we've got some like terms we need to combine before we can go any further. So we've got X. What's negative 20 plus 70? Or think of it as 70 minus 20. 50 equals 180. Okay, now we're going to subtract 50. Some of these I'll work a little bit further than others. And we get x equals 130. Now, x equals 130. That doesn't mean the angle degree is 130, but that means x equals 130. So it's important to look at what the question is asking. In this particular question, it's just simply asking, what is the value of x? So you're done. Because that's what we got, x equals 130. If it asked the angle measurement of that, it would be 130 minus 20, so it would actually be 110. And does 110 plus 70 equal 180? So we know our calculations are correct, okay? But it just asked the value of x, so simply answer the question, x equals 130. All right, go on to 6-9. This is the one where I'm going to do a lot more work with you, okay? I'm going to help you out on this one. All right, so it says, what is the measurement of angle 4? Okay, let's look at our graph here. Let's find it. First of all, let's find what we're looking for. We're looking for that. Okay, there's angle 4. That's what we need to know. Angle 4 sits on a straight line right here with these other two. Now, it's okay. So far, all we've done is 2 angles that equal 180. But it's okay to have 3 because it's just like slices of pie, right? You can cut a pie in 4ths, or you can cut a pie in 6ths or 8ths or whatever. Half of that pie is made up of these 3 angle measurements. What do all 3 of them have to add up to? 180. So I know that the measurement of angle 4, which I don't know yet, plus 60 plus 61, I know equals 180. Now, you do not have to set up this equation. I'm just showing you the mental aspect of what we're doing here. So if you add up 60 and 61, what do you get? 121. So if those two equal 121, subtract that from 180 to give you what the measurement of angle 4 equals. What is it? Everybody agree? All right, so I can come up here and I can say the measurement of angle 4 equals 59 degrees. Now it wants 1, 2, and 3. Well, let's go back over to our graph, and I'm just going to erase what I've done so far, and I'm going to fill in now. I know that angle 4 equals 59 degrees. Okay. If you are looking at this parallel line, and this transversal, okay, you can ignore the other one for right now. If this angle is 59 right here, what do we know about the alternate interior angle? It's also what? 59, okay? So let me erase all that so I've got room to write. Okay, I now know that this one equals 59 degrees, right? Because of the interior opposite rule. So I'm going to come over here. The measurement of angle 1, I know is 59. I know I'm also going to need the measurement of angle 2, and they want to know the measurement of angle 3. All right, let's go with what we can get next. Looking at the triangle, and I'm looking at this triangle right here. If I know that one angle is 60 and one angle is 59, what do I know about this angle? What are you going to subtract that from? 180. So everybody should punch this into your calculator. 180 minus 59 minus 60. And if you don't have a calculator in front of you, I'm going to call on you to give me the answer. Get you all jumping. Let's go. Or if you want to do it by hand, I don't care, but well, it's not 121. It's adding up the interior angles of this triangle right here. This is the one we're looking at right here. No, it's 180 minus 60 minus 59, because those are the interior angles of that little triangle. Olivia? 61. Okay, somebody confirm it. 61. Okay, so we know angle 2 is 61 degrees. And what did I forget? Nobody caught me. I forgot my little degree symbol. All right, now, if we know that angle 2 is 61 degrees, what do we know about angle 3? It's got to add up to what with 2? 180. So now you can find angle 3. Maddie R? 119. Good. Anybody confirm it? So I'm not checking it. Okay. 119 plus 61 gives you this straight line right here. Okay, two angles added together have to equal 180. If you know one is 61, that means the other one has to be, and what did we say, 119?
Yeah.
Okay. And if you want to test yourself just to make sure you're right, what should these two added up together give you? Yeah, because they're interior adjacent. They're right next door to each other on the inside, so they got to add up to 180. Good. All right, so we were able to answer all of those just by simply having the 60 and 61, but it's just kind of that you got to kind of follow the pattern or follow the yellow brick road. I don't know why, that's just what popped into my head. You have to kind of follow what you can get, right? You find 4, then if you find 4, you can find 1, then with 1, I mean, you just kind of have to keep, just remember 180 is your friend. Go back to that 180. Straight lines have to add up to 180. Interior triangle angles have to add up to 180. All right. Now this one I want to work with you because we have not done one like this. So I'm going to color code everything here. We've got Q is this, 11x minus 5. We've got P is 6x plus 5. And we've got R equals X. Now none of those are numbers, but we still know those are 3 interior angles of a triangle. So if we add up all 3 of those together, what should it equal? 180. So let's do it. Let's go 11x minus 5 plus the blue one, 6x plus 5, plus the purple one, which is just x. And if we want to put the 1 there, that can be helpful. And we know that those all have to equal 180 because it's 3 interior angles. Now, before we start moving and trying to solve for x, let's combine like terms. We have 11x, 6x, and 1x. That's like saying in the left basket, we have 11 apples, 6 apples, and 1 apple. How many apples do we have altogether? 18 apples, or in this case, 18 x's, right? What about the 5s? What happens there? -5 and +5 in this particular case, what happens? Yeah, no, they don't go to 1. If you have 5 apples and you take away 5 apples, you have none. If you have -5 and 5, they zero out. So just equals 180. Olivia?
Are you supposed to put your degrees in where you...
Not when you're working the problem, just in your final answer. Yeah. Technically, it's 180 degrees is what we're trying to get to, but right now we're just trying to solve for x, so I wouldn't worry about putting it in there yet. All right, what's my next step? Divide by 18. Good. Divide by 18. I do that because I want that to go to a 1, and it does, so I don't even have to write it. So I know x equals 10. Now, does the problem say what's the value of x? No, so we're not done. We got to go one at a time. So I'm going to take the red one first. The red one is 11x minus 5, right? And that equals Q. Well, let's do this. Let me do this the other way. Sorry. The measurement of angle Q equals 11x minus 5. But now what do I know about x? It's 10. So the measurement of angle Q equals 11 times 10 minus 5. What's 11 times 10? 110 minus 5. So the measurement of angle Q equals 105. And that's where you put the degrees, Olivia. So we now know the measurement of angle Q. Now let's go to the blue one. The measurement of angle P is, now I'm just going to go ahead and plug the 10 in right now. 6. Oh, I'm sorry. Thank you. Good catch. It doesn't even ask for all of them. No, good catch. You're right. Sorry, I was getting excited and I was going to find all of them. You don't have to. The directions just simply say what is angle Q. We found it. Good catch. Thank you. If they wanted P and X, it's easy. What's angle X? Or what's angle R, I mean?
10.
It's just 10 because it's just plain OX. All right, very good. But we didn't even have to do that because we didn't need P and R. Very good. Okay. All right, here's the one I want to do with you because there is a bonus on your test worth 10 points. That's a full letter grade. And I want everybody to get it because we've done this already. It's nothing new, but I want to show it to you. If you're trying to prove similarity, and you can, remember I said you can compare coordinates and make a ratio out of coordinates. You can compare side lengths and make a ratio out of side lengths, or you can compare angles and make a ratio out of like angles, but you got to know what's alike. So E and A are kind of the long tip of this triangle. So we know that E and A are coordinating. So we're going to make a fraction out of E and A. So that's 18 over 18. Everybody see that? It equals 1. Which coordinate of EFD coordinates with B? Which vertice? F. That's the obtuse one, right? So we need F. I can't compare them unless I know them. What's F? Are we sure? Add up 18 and 52 and subtract that from 180. Yeah, so we got 180 minus 18 minus 52. Okay, so 110. Well, what's angle B? Also 110. Same ratio. Okay, so are these similar? Yes, because each coordinating vertices have the same ratio. Okay, they all reduce to 1. Do I even need to do D because we know that this one is 52, and so we know that 52 over 52 is also 1. Okay? All right, how about this one? Could you do this one without any math?
Yes.
If they share C, can you do the ray test?
Yep.
They're perfect dilations of each other, so are they similar? Yep. So in your explanation, it passes the ray test from vertice C. Okay, I'm good with that as an explanation because that shows me you understood what you were doing. Now here's the one we're going to work all the way together. I know, right? Because this is your bonus. And this is worth 10 points on your test, but it's bonus points. And like I said, that will bump everybody up a full letter grade. All right. Notice we do not have anything that tells us anything is parallel, right? So we cannot use any transversal rules. But even without parallel lines and transversal rules, this rule applies to every single intersecting line on the planet. Okay, and I'm going to show you this. This is always equal to its opposite angle, always. Anytime you have two lines that cross, opposite angles are always congruent. So that means that without knowing anything at all about parallel lines, I can't use a transversal rule, but what I can say is this equals this because they're opposite each other. So that means I can set up an equation, 6x minus 2 equals 5x plus 10. I know those two are equal because they are across from each other. So let's solve for x. Okay, I'm going to subtract 5x because I want to get all my x's over to the one side. So I want to get it off that side. That leaves me with 1x minus 2 equals 10. Now I'm going to add 2 to both sides so that I know that x equals 12. Now a little bit of work comes in here because here I know that x equals 12. So I'm going to take that to everywhere that I now have. If I know that this angle right here is 5 times 12, because I know x now, right? 5 times 12. What is the measurement of angle J? 60. All right, so I'm going to put a 60 right here. If I know that the red one is 6x minus 2, I'm going to go 6 times 12 minus 2. So what is the angle, or what is the measurement of angle L? 70. It's 6 times 12, which is 72, minus 2, which is 70. If I know that one is 70, what do I also know the blue one equals? 70, because they're across from each other, right? Yes. Angle L. And they share angle L, which is why I know they equaled each other and why I can say 70 and 70. Now, just look at JKL. If I know that this angle is 60 and I know that this angle is 70, what do I know about this angle? If you know 2, you can always find the third by subtracting them from 180. Okay, do I get a second? Anybody? Okay. Whoops, so now I know that this one is 50 degrees. Okay, let's do the same thing over here. Oh, whoops, I didn't do M yet. I'm sorry. Got ahead of myself. Well, if you know that this angle right here is 60, and you know that this angle is 70, the 3 inside interior angles of a triangle have to equal what? 180? So if you take, yeah, if you add 60 and 70, you get 130. Take that from 180 and that gives you 50. And then over here, I forgot, I need to do a little bit more work here. I forgot. I've got 6 times 12 minus 7. What's my M angle? Everybody agree?
Yeah.
65 degrees. Okay. And now that I know 2, I can find N. Somebody tell me what N is. Do I get a second? Punch in your calculator. 180 minus 70. Double check it. 180 minus 70 minus 65 is 45. All right, so now let's go to our options here and see what they're asking us, okay? The first says that you have only one pair of congruent angles. Is that true? 70 and 70, those are the only ones that are the same, right? So that one is true. If you only have one pair, can you have 2 pairs? So we can mark that one out. JKL has angles 50, 60, and 70. Is that true? Okay, so that's one. LMN is 50, 60, 70. Nope. They are similar. Put L over L. What do you get? 1. Is that right? 70 over 70 reduces to 1. If you put K over N, do you get 1? If you put M over J, do you get 1? If you put J over N, there's no combination that will give you a ratio, right? So, are they similar? No. Yes, Brady?
No, I was just checking.
Oh, okay. All right. Here's the deal. Okay, this packet is due Friday at the beginning of class. We will take the test on Friday. At some point during the hour, you will be able to use your packet on the test, not the whole time, but maybe half the hour, you will be able to use your packet. So getting it done, not only, hang on guys, don't put away. Pay attention, don't put away. Not only is the packet worth 20 points, because it's a big packet, so I made it worth a lot more. Not only is it worth 20 points, but it's going to help you on your test. So double reason to get it done. All the hints I've given you will help you complete it fully. You have class time tomorrow, but that will not be enough. So some of this is going to have to be done outside of class. And go back right before the test and look at this number 5 that we just did, because I really want everybody to have a good shot at that bonus 10 points. Okay? All right, that's all I have for you. If you're anybody at home and you need help, shoot me an email.